Inverse trig functions. In this lesson, we're going to be looking at the inverse sine, inverse cosine, and inverse tangent functions. Now, I've reproduced the unit circle here, which is going to help us out a lot with this discussion here. Let's start out doing a review problem over here off to the right. Just something simple. Suppose the question is, let's find the sine of the pi over 3. Now, you know how to do that. You would search for the pi over 3 on the unit circle. We find it in quadrant 1, right here. And the sine is always equal to the y-coordinate. So there it is. It's equal to the square root of 3 over 2. And there is our answer. Input's pi over 3, output is square root of 3 over 2. Now, let's contrast that with the inverse sine. By the way, inverse sine is sometimes pronounced arc sine. Now, in the inverse sine, as with all inverse functions, essentially our inputs and our outputs are reversed. So the inverse sine, if we want to do a problem similar to the one right above it, we'd say, what is the inverse sine of the square root of 3 over 2? Now, in that case, we would look at our unit circle, and it would just be the reverse. We know that the y value is supposed to be square root of 3 over 2. So we see, of course, I still have that circled. And so what the inverse sine is doing is it's giving you the sine and asking you what would be the angle. So the angle would be pi over 3. And if you compare these two statements, you'll see what I mean. Our pi over 3 and our square root of 3 over 2 are just reversed. The input becomes the output, and vice versa. But before we move on, and conclude, oh, this is simple, imagine someone else who just jumped in on this presentation. That person, and suppose that person says, oh, I see where the square root of 3 over 2 is, but they don't spot it in quadrant 1 like we did. Suppose they spot it over here where you see me circling it in quadrant 2. Now, we couldn't argue with that logic, right? The y value over there in quadrant 2 is square root of 3 over 2. The problem is that person would say, oh, so the inverse sine of square root of 3 over 2 is, and they would respond here with 2 pi over 3. And we'd have a problem. We'd be disagreeing. We'd have two different answers. Recall that when you have a function, you're always supposed to have a unique answer. So one of these has to be eliminated. What we do, as is the case generally with all inverse functions, is we restrict the values. And in the case of the inverse sine, what we will do is we'll take our unit circle, split it in half, and we will agree to only search in quadrants 1 and 4. That is the right-hand side. So that's what you want to remember. Inverse sine, always look only in quadrants 1 and in quadrants 4. Okay, so I've reproduced the right-hand side, but I want you to notice there's one significant difference. Notice that as I go down here, that I'm using negative values to describe these angles. So that negative pi over 6, on the full unit circle, we normally call that 11 pi over 6. You want to describe it using negatives. In other words, you're starting at 0 radians in the center, and you're going up for positive, down for negatives. Now, as long as we keep that convention in mind, we can easily handle any problem. So, for instance, how about the inverse sine of negative 1/2? All right, so it is an inverse sine, so we want to be looking for the y value. And notice the only place you'll find that is down here in quadrant 4. So the appropriate angle there would be equal to minus pi over 6. So I want to say it one more time. Don't call that 11 pi over 6. When we're doing the inverse sine, we use negative angles when we count down into quadrant 4. Let's now look at the inverse cosine. And this probably won't surprise you when I say that we're going to run into roughly the same sorts of issues. So for inverse cosine, I will propose this problem here. Inverse cosine of the square root of 2 over 2. So that's saying that we want to find the angle that has a cosine equal to square root of 2 over 2. Now remember, with cosine we look at the x value. So where do we find that? Well, I'll circle it over here. I see it right here, a positive square root of 2 over 2. So it looks like I could say that the angle was pi over 4. But if you're really on your toes, you might notice that, oh yeah, but you also could have spotted this same value down here in quadrant 4. Yeah, that's true. And so just like the inverse sine, we have to restrict our search area. And with inverse cosine, it's a little different. You split it here along the x-axis, and we will reject quadrants 3 and 4, and our answer therefore will always be an answer from quadrant 1 and 2. Notice all of our cosine values are different there, so we won't run into any ambiguities this way. So let's look at another example of an inverse cosine. This time let's let it be the inverse cosine of the square root of 3 over 2. So the answer will be an angle, and you want to find where the cosine is equal to square root of 3 over 2. That will be the x value. Notice you'll find it right here in quadrant 1. And notice you will not find it in quadrant 2 because there it would be a negative value. And so our answer will be uniquely be pi over 6. Now if we hadn't restricted our search area, we would have found a similar value down here in quadrant 4, but that's simply off the table when we're looking at inverse cosine. Inverse tangent has the same sorts of considerations as the other. You would always get two answers if you searched the entire unit circle. Inverse tangent, turns out that we want to use the same search area as we did for inverse sine. So we're going to be looking at quadrants 1 and 4. And here I'll give you an example. Inverse tangent of 1. Now inverse tangent is a little bit trickier because you have to think of ratios, because that's neither going to be x nor y. That's going to be the ratio of y over x. So we need to look at these values here on the unit circle and see if we form a fraction of those, will we ever get a 1? Well, in order to get a 1, the x and the y values would have to be identical. Oh, there they are at square root of 2 over 2, comma, square root of 2 over 2. So the angle that corresponds to this would be the angle pi over 4. I want you to notice we're close down here, but the ratio there would give a negative 1. One more important thing before we sign out of this lesson. Just as in inverse sine, when we're looking at the right-hand side of the unit circle, we don't call these values, for instance, we don't call that 11 pi over 6. We count down. So negative pi over 6, negative pi over 4, and so on. Just make sure you make that adjustment. So the trick with these inverse trig functions is remembering the appropriate search areas, and you should do just fine on them. All right, good luck, folks.